Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Adam Kriegel, Senior Audio Software Engineering Manager at Apple. Adam is a Carnegie Mellon graduate with both bachelor's and master's degrees in electrical and computer engineering and a minor in audio engineering. If CMU allowed it, I think Adam could have claimed a second minor or maybe even a second major in Blahakis Recording Studio for all the time he spent in this very room during his time at Carnegie Mellon. Please welcome Adam Kriegel to the Music and Technology Seminar.
All right, thank you. Thanks, Ricardo. Let me share my screen and my slides. Please let me know. Are you all able to see the slide deck here?
I think so.
Okay, awesome. All right, I will get started then. All right. Oh, actually, let me stay here for a second. Thanks. First off, I want to say thanks to Ricardo for inviting me to speak here today. I guess about a decade ago, I was in the same position that you're all in, attending all the same classes in the same rooms with much of the same professors. So it's really exciting to be able to come and talk to you today, and looking forward to getting to share some of the things I've been working on. So I'm going to start today with an overview of my background and talk about my path to audio software at Apple. I think that could be helpful, maybe informative for those of you who might be curious. And then I'm going to talk a little bit about what I currently do, what the team that I'm in charge of does for Apple. And then after that, I'm going to go through and give a very quick overview talk about the world of audio software. So I'm going to tell that from the perspective of an audio driver, and I'm going to glaze over a lot of details outside of that and even within that. So yeah, with that, I can go ahead and get started. So I had to include this picture. It's kind of a funny picture, but you can see it's in the room that some of you are sitting in right there. I like this one. It's one of the only ones that I could find where I was in the recording studio, but as Ricardo mentioned, I spent a lot of time there. And I think this is an especially funny picture because you can see I'm in front of the really, the large console, and all I've got going on the screen there is a 2-track recording. So all the faders set to 0, not a lot really going on. But anyway, I thought that was funny. So I grew up, maybe similar to a lot of you, I grew up with a strong interest in math, science, and music. And I couldn't really figure out a way to string all those things together into a career. So I sort of said, okay, well, if I can't put all those together, maybe I can focus on engineering. That at least gets me toward math and science. And music could just be a hobby for me. So I signed up to go to Carnegie Mellon to study electrical and computer engineering, and was really happy. I think Professor Sullivan is also on the call here. He was my professor for Intro to Electrical and Computer Engineering. And that was the first class that I took at Carnegie Mellon. And about a month into that class, he made an announcement to everybody saying, hey, I'm doing this new minor called audio engineering. If anyone's interested, please come talk to me. That was for me like a, light bulb moment. That was the point where I could finally connect the dots and say, hey, maybe I could put all of these things together into a career, into a profession. And so yeah, I really want to just say thank you to Professor Sullivan for that. And then that also launched me into the world of all of the other things that were going on with recording and audio at Carnegie Mellon. So that's where I became introduced to Ricardo and all the classes that are offered in the recording studio, which ultimately turned into a part-time job on campus. And would recommend, if any of you have the opportunity to work for Ricardo, that is a really cool job. You basically get paid to set up equipment and then listen to amazing musicians for an hour or 2 or 3 hours, and then tear down the equipment. So great way to make a little money on the side if you have the opportunity. Following my junior year, I interned for the Boeing company, and I worked in their noise and vibration department. that was a fun internship, but ultimately wasn't exactly what I wanted to do. So the following summer after my senior year, I went on to intern for Apple, working in what was called the iPod audio group. Not sure if you all know what an iPod is. That seems, 10 years ago seems like a pretty antiquated technology, but it was a really cool opportunity. I had an iPod when I was younger, and so the ability to go in and work on one of the last versions of that product was really cool. After my internship, I went back and completed my integrated master's and bachelor's. During that time, I TA'd for Intro to ECE, and continued to work with Professor Richard Stern on some signal processing stuff. So really just had a phenomenal experience at Carnegie Mellon that I think situated me to where I'm at today, which is working full-time at Apple in audio. After I finished my master's degree, I came on full-time at Apple. That was back in 2013, working on a team that was called audio prototyping. We were really dedicated toward this new product that was called HomePod, that some of you may be familiar with, but it's sort of like a Sonos speaker. It's an Apple smart speaker. But for secrecy reasons, we just referred to that as prototyping. And that was a really awesome experience because I got to work in a big company the size of Apple that felt kind of like a startup. We didn't have the same product deliverables as some things like iPhone or Mac that are really on this very rigid cadence of delivery and update. We got to be a little bit more experimental about what features we were considering and how we wanted to architect those. So that was an awesome post-college experience because I got the benefit of a big organization with also the benefit of what felt like a startup. I focused on that time on spatial audio. So I worked on various upmixing algorithms, things that would take stereo audio and somehow make it so that it sounded Apple calls it room filling sound. Sounds bigger than just the speaker that it's coming from. And so we looked at different beamforming techniques. We looked at different ambience extraction, center channel extraction algorithms. And then we also looked at automatic rendering algorithms. So we tried to figure out, can the speaker determine where it should be playing all of this stuff? So really fun project to work on. I did that for about 5 years. And then in 2017, around the time that the HomePod launched, I transitioned into management. And it's kind of grown from there. I originally started off managing the team that was in charge of audio for HomePod. And then that sort of grew a little bit. So then it was all of home. So HomePod, Apple TV, and then this new product called Apple Studio Display. Manage the team that's in charge of Apple's class audio drivers. The way to think of a class audio driver is if you plug something into your iPhone or your Mac or your Apple TV, that thing often will need a driver that can run audio to it. And unless you want to download a third-party driver that the manufacturer has created, you can get these sort of built-in for free drivers that are implemented against a class spec. So Apple has many of those, some of which are for USB, HDMI, and audio video bridging, which is a networked audio technology. So that's a quick whirlwind background about how I ended up where I am today. And if there are any questions, we can probably save those to the end if folks have any questions about that. But now I'll change gears a little bit and talk about audio drivers. So the title of the talk was "What Happens When You Press Play?" I spent a long time trying to come up with a better pun about, I don't know, drivers and something, cars, but ultimately this is what I came up with. And the subtitle, of course, being an overview of audio software. So I understand that many of you in the class might not go on to work in audio software, but I imagine that most of you will go on to use audio software. And I think there are a few really important concepts that will make navigating digital audio a lot easier. Things like sampling rate, buffer size, latency, buffers, those things. So I'm going to try to give a quick overview of those from the perspective of a driver engineer. Yeah, we'll see what kind of interesting things we can find. So this is my very mock-up quick example of an audio software system. You can see that the flow of audio data here goes from application software. Here I'm using the music app. Let's say that's running on a Mac computer. And that then passes audio data to an audio engine, who passes data to an audio driver, who passes audio data to this digital to analog converter, which ultimately gets to the speaker, and you can hear that. So pretty simple, but if you zoom in and kind of look at some of the details here, there are some interesting, more complex pieces. So we're going to focus mostly on the middle part of this chart, because I'm not an application developer and I'm also not an acoustician. A joke I like to tell people is that I'm an audio software engineer because I'm not so great at audio and I'm not so great at software, but I'm pretty good at audio software. So let's take a closer look. We'll start at the end and work our way backwards. At a very high level, the speaker works by creating a disturbance in the air, which is received at your eardrum as sound. Obviously, glazing over a lot of details here, but high level, that's how it works. And ultimately, something has to tell the speaker how to create that disturbance. So in our example, that is the DAC, or the digital to analog converter. The job of a DAC is to take a digital value and turn that into some analog voltage. That voltage is then used to move the speaker diaphragm. Usually the values fed into the DAC are some ranged values, so like something between -1 and 1. Those are probably what you may be familiar with. DACs are often characterized on things like total harmonic distortion. Basically, what's the quality of their ability to represent the digital signal that they've been fed. I'm not going to spend a ton of time talking about that, but for this talk, what really is important is making sure that we can play back audio without glitching. And so in order to do that, we have to make sure that we're updating the DAC at a constant rate. So the DAC is going to be driven with some clock, and the clock is going to tick at an audio rate. This might be, let's say, 16 kilohertz or 44.1 kilohertz, 48 kilohertz. But the important thing is every time that this clock ticks, we have to update the value that we feed into the DAC so that it can update the value that it outputs. So, in the illustration, tick in time, update the value, tick in time, update the value. As you can see from the bottom here, the value that we're feeding into the DAC is coming from a buffer, and those values have to come from our audio driver. The audio driver has many responsibilities. One of them is, of course, to be the interface between the operating system and this piece of hardware, this DAC in this case. But another is to ensure that there are always audio samples available in the DAC's buffer when the clock ticks. If there are no samples available for the DAC to update, that will cause a discontinuity, which will sound to the listener like a glitch. It's obviously an unpleasant thing for the listener to hear, but depending on the output, it could also be damaging to your hardware. So this is the kind of thing we want to avoid at all costs. That's sort of like #1 responsibility for the driver. So the way that we can guarantee that the buffer is not going to run dry, is not going to be empty as the DAC ticks through, is by conveying some pieces of information to an audio engine. And then that audio engine will try to model where the DAC is reading from the buffer, so that it can make sure it's writing samples, sufficient number of samples ahead of that. The pieces of information here that we're going to give are sampling rate, of course. That's the rate at which we think the DAC is progressing through the buffer. A periodic timestamp, I'll make a note about that in a minute, and this fudge factor that we're going to call the safety offset. So the timestamp is an important piece of information because what I didn't mention in the last slide is that often the clock that we're using to drive the DAC and progress through this buffer is not the same as the clock that's being used on the operating system. That is usually host time. That could be, let's say, it may or may not be the same clock they use for the DAC. And if it's not, which in many cases it's not, you need to make sure that the audio engine is able to compensate for there being a different rate of consumption of that DAC, asynchronous to the rate that it might be trying to fill. So we got to make sure we model that. And then the safety offset piece here. Safety offset is a value that we use to represent unpredictability in where the DAC might be reading from the location. There are many hardware-specific reasons why this value might be larger or smaller. But in our example, this could be something like jitter on the clock. Maybe the clock is not as consistent as we would like. So that number is effectively going to tell the audio engine that the DAC is somewhere between 0 and that number of samples behind where the audio engine might think for hardware-specific reasons. And it's not going to be able to model those. So let's just be safe. Write all your samples ahead of that to make sure that we're not going to run the read head of the DAC into where the audio engine is trying to write. Another example here is for USB audio. This could be caused by unpredictable transfer times of USB audio samples. So it could be anything specific to the hardware that might make it difficult to model where the DAC is reading from. Okay, so at a cadence that's defined by our sampling rate and also defined by our I/O buffer size, that's a slightly different concept. The audio engine is going to hand a buffer of samples to the driver that it can write into the DAC's buffer. So in this example that I've given here, let's make an assumption that we're running audio at 48 kilohertz. In that case, if I had a 6-sample I/O buffer, I would be looking at 125 microseconds worth of audio data. That 125 microseconds of data needs to be placed into the buffer exactly at that cadence, 125 microseconds, to make sure that you're matching the amount of data that you're producing and consuming. Give me 1 second to grab some water. And actually, let me make sure I have my, just realized I don't have do not disturb on. Okay. So the samples that we're getting here for this I/O buffer, they had to come from somewhere. And that somewhere is actually the top of our stack, the application that we looked at on the first slide. The process of transferring these samples, it takes some time. It's not an instantaneous thing. And so, so the reasons behind that can be things like signal processing. So, it might be that you would like to put reverb or put a distortion signal, something on top of the samples that you're producing. It might be that you're trying to copy the data and that takes a little bit of time, or it could be nature of using a non-real-time operating system, that you're waiting on other stuff on the system to do work. It could be even the mail application on your Mac is running some processing that slows down the transfer of that data to get into the DMA buffer. So as a result, the audio engine has to account for that. And so it needs to make sure that it's actually writing the buffer of data, not exactly ahead of the safety offset, but actually one buffer into the future. This ensures that the hardware buffer isn't going to run dry in the case that populating that buffer takes an entire I/O cycle worth of time. If populating the buffer were to take longer than one I/O cycle's worth of time, a glitch would occur. So some of you may have encountered something like this if you had, let's say you had Pro Tools or Logic running and you added a bunch of plugins to one of your channels. As you add, let's say 10, 15, 20, 30 different plugins on there, at some point your system will start to glitch. It'll start to overload. The reason why that's happening is because the amount of processing time that it's required to produce the samples that you need to give to the speaker that you're listening on, it starts to exceed the amount of time that corresponds to the size of the buffer that you're using. So yeah, ultimately you get a glitch if you go over that amount of time. So this is kind of I guess a good pause point to look at another very important part of audio software, which is latency. So a good way to think of latency is the amount of time that a sample has been sitting in a buffer until that sample is ready to be played on the speaker. So for our example here, we don't have any real-time producers of audio samples. We're here looking at a case where we've got music that we're reading from disk. The music is always available as it's being requested by the audio engine to the application. So we'll look at this first sample in the buffer and then compare that to the green sample. That's the point at which it's being read by the DAC. So if we figure out the time between the red sample and the green sample, that will tell us our play to sound latency of the speaker. And how long is that going to wait? Well, ultimately, it'll depend on these two variables that we've defined here. There's the safety offset and the buffer size. So for our example here, we're looking at 6 samples of safety offset, 6 samples of buffer size running at 48 kilohertz. In this example, we ended up with 250 microseconds of latency. So that's a really quick whirlwind walk through audio drivers and some examples there. So we'll just do a quick summary here. Ultimately, the process starts with our audio application. It's producing some buffer of audio data that's been requested by the audio engine. The audio engine will then hand that data at a specific cadence to our audio driver. The audio driver will interface with our hardware. So it will put the data into a buffer that is ultimately going to be read by our digital to analog converter. And the digital analog converter will use that information to drive our speaker. And that's my quick overview of audio software. So Ricardo maybe went, I guess, a little faster than I was expecting, maybe than you were expecting.
Okay, we have time for questions and
ample time for questions. Yeah.
Go ahead. Anyone have a question?
I have a question if no one else does.
Yes, go ahead.
Yeah, so there's also I mean, so I'm not sure what happens on like Apple speaker devices or other special hardware, but on laptops there's also an interface to applications. And typically those they're much larger buffers. Like you're not waking up the application every 6 samples, but there's some programmable buffer size. And so I really have a question about some design choices on the in Mac OS, and so I don't know if you know the answer, but it looks to me like when you request a certain buffer size, that the system always does double buffering with the application,
Yeah.
which adds, I mean, that can have an impact on latency. So for example, if instead of double buffering with 2 buffers, if you could have a more fine grain buffer sizes, but have multiple buffers queued up, then you could reduce the overall latency. I don't know if that makes sense, but
Yeah, I'm trying to think through specifically. So I think you might be getting to the point that I brought up here, where effectively we add in a buffer size of latency here beyond the safety offset. So you're saying that if the IO buffer size of the application was 1024, for example,
Mhm.
you're saying that the latency that that you would experience would be 1024 plus another 1024 plus the safety offset.
Right.
And I think that that's due to the nature of the processing delay that I was maybe trying or not so well explaining there, where we need some amount of time for the audio application to process that data. And so if we were to eliminate the second IO buffer that's there, there would be cases where we would cause a glitch, because if you were to process for the entire, let's say 1024 over 48 is I can't do the math that fast, 21 milliseconds, I think. If you were to process for that entire 21 milliseconds, you would have cases where the last sample that you drop in there would cause a glitch in the audio playback. And so as a result, we have this, I guess, you're referring to as the double buffering there, to ensure that we always have at least that full buffer. Applications that are expedient, unfortunately, then will sit there for the entire processing time, because some applications may need that full IO time to produce the data. There are internal mechanisms we have to reduce that. So if, for example, I knew that the DSP was only going to consume 50% of the processing time, and that I had special guards in place to make sure that I wasn't going to be preempted by other things on the OS, like VM paging or things like that, I could back that off to 50% or 25%. But that's a control that we don't expose to customers, just because it's, it can be fairly dangerous if things on the OS happen that are outside of your control, that ultimately, could cause glitching every single cycle for audio playback.
Yeah. So in contrast, on Windows, the driver model and first of all, Windows is pretty terrible in terms of audio and overall operating system latency.
Mhm.
So I recognize that even with the double buffering,
We're pretty low. Yeah.
Apple performance is much higher. But on Windows, you can set up, applications can set up an interface to the driver where, instead of double buffering 1,000 sample buffers, they can do 8 buffers of 256.
Okay.
And that effectively cuts the overall latency in half, or almost in half.
Yeah, I'm not familiar with that mechanism. Yeah, I'd need to poke around and explore a little. And we certainly allow you to reduce the buffer size. I think we allow on macOS, we allow as low as 14 samples. And that can be specified by the application. So Audacity, for example, could specify or could request that that it wants a smaller block size. But I'm not sure. Yeah, I'm not familiar with the concept of queuing up multiple smaller buffers.
Yeah, maybe we can talk offline.
Sure. Yeah, feel free to send me an email. Something. Yeah.
To me, it just seems like a design flaw in Apple, which has done everything else so well. But
yeah, well, yeah, let me know. I mean, as you point out, we are extremely low latency compared to Windows, and that's something that we prioritize. Even our USB class driver, we've gotten that down to sub 5 millisecond latency for round trip, which is great. That's almost where we need to be in terms of supporting monitoring use cases and things. So something that we'd like to continue to improve on. If you want to send me an email, discuss further.
Okay. Yeah, great. Thanks.
Yeah, so Adam, I have a few questions. I remember many years ago, we had a previous conversation about what you were doing at Apple, and you told me some project you were working on, which sounded, really important at the time. But I asked you, why were you doing code on that project? Because you're an ECE person. And you told me, well, they wanted somebody who knew both. And that just happened to be you doing your internship in the summer. So the audio drivers, how much of it is hardware and how much of it is software?
Yeah. So I guess that gets back to my joke about audio. I'm not that good at audio and I'm not that good at software. So I'm pretty good at audio software. Um, I think it's not quite 50-50. But let's say like maybe 25% of my time is working with double E's and reviewing schematics and making sure that we've got the correct pinouts and things so that our drivers are properly connected. Some of that's reviewing spec sheets and data sheets and things. But I would say, yeah, maybe 75%, maybe the majority of my time is going toward writing the software that supports those and interfacing with the operating system. Yeah, operating systems are extremely complex beasts, and there's a lot of things on Mac OS, iOS that are not really set up to work well with audio. I sort of, barely touched on the fact that these are not real-time operating systems, and so most of the operations you would like to do are unbounded. So you have to be very careful about the type of code that you're writing to make sure it's real-time safe, and yeah, the devil's in the detail for that. So making sure that we've got the hardware set up, yeah, that's part of the job, and then making sure that we've got the software that's correctly written to interface with that hardware is probably the majority of the job. Yeah. And some DSP sprinkled in there too. I've still maintained some DSP. Yeah.
Okay. So I have other questions too, but is there anyone else who has a question? Yeah, go ahead.
Maybe more of a hardware question. For the products you work on, are the amplifier and preamplifier ICs integrated into the DAC chip, or are they separate chips usually? Or
It is usually the same chip. For this example, I totally glazed over that detail. Yeah, but usually there's going to be there's going to be a need to amplify the signal that comes out of the DAC, and often what we're using are integrated.
So, hi Adam, thank you so much for this talk. I wonder whether can you hear me clearly or not?
I can hear you. Yes. Yeah.
Thank you so much. So my question is mostly about management and research. So I remember you firstly said that at the first time you joined Apple as a full-time employee, your team is working like a startups group that there was no steady deliverables. So that triggers me a little bit because I thought, okay, it is actually a little bit hard to think about how can multiple people to work collaboratively to explore new things, and especially you're working in a large corporation, which means that they might want you to spend a short period of time to have some fruitful product. So I just wondered about how did you and your other colleagues working as a team to make to deliver stuff that could be useful for the corporation, given that there is no clear and foreseeable target that you need to work on. I just wondered about the whole progress. Can you elaborate this a little bit?
Yeah, that's a very good question. And I can explain maybe how I've witnessed Apple handle this challenge. So you're probably familiar with the Vision Pro, this AR VR headset that Apple just released. The HomePod had similar structure as well. Yeah, so Apple typically operates on very strict deadline and strict cadence. So if you use an iPhone or if you use a Mac, you know that we typically have a major software update once per year. We typically have once a month or once every 2 months these minor software updates that are happening in between those major release cycles. And then our product release cadences are also pretty similarly scheduled. They tend to be every year or every 2 years. And so you have part of the company that's operating in this very like mechanical way, where we have super strict schedules and deadlines and formulas for how we release that software. And then seems like the pattern that we've taken for products that need longer release cycles or they need more R&D with them is we sort of spin off these like mini companies that go and work on things. So for the Vision Pro, you had an entire group of engineers that was purely dedicated to that technology. They worked on that for several years. And then as the product was preparing for ship, they started to integrate that group back in with the rest of the company that was more on the regular product release cadence and cycle. There are definitely pain points with that process, because people who have just had 5 years, 6 years, without strict deadlines, maybe some challenges fitting in with bug management and tighter timelines and deadlines and things. But that's the model that we followed for HomePod. It's the model they followed for Vision Pro. It's the model they were following for Project Titan stuff. So yeah, I would say anyway, maybe not a great answer to your question, but basically we sort of follow two different models, and that seems to be doing a pretty good job of making sure that we can not destabilize the already shipping products while bringing new products into the fold.
Thank you.
Okay, so Adam, I wonder if you could say something about how do you get a job at Apple? Are Carnegie Mellon students doing the right things in what courses they're taking? And do they do internships, and what is the deadline, and how do they apply and, make sure that the application is looked at?
You read my mind, Ricardo. I had a very similar question about, are we doing the right things for our students to feed them into your environment? Now that you're in management, I assume you're doing hiring and things like that now, Adam. What kinds of things do you want to see for people coming to ask you for a job?
Yeah, great question. So the first half of that was, is Carnegie Mellon doing the right things? From my perspective, absolutely. So I walk around Apple Park and I'm just seeing alums, people that I was in classes with 10 years. So a lot of people that I went to Carnegie Mellon with ended up at Apple. So I would say absolutely the coursework seems to be properly geared toward a career at Apple. More specifically turning toward what am I looking for on resumes and things. So my group, so at this point I manage managers. I have a couple of engineers that report to me, but for the most part, it's the managers that I'm managing who are hiring. We have 2 interns that are coming on this summer. We have 2 full-time positions that are currently open, and then a couple more full-time positions that are coming down the pipe. Those are all things that get posted on Apple's job website. You can apply for, but Carnegie Mellon also has kind of a fast track that I was able to utilize, where the Career Center has a relationship with Apple. And so we send people to Carnegie Mellon for job fairs. If you reach out to people in the Career Center, they can connect you with recruiters who are specifically set up to field students from these top universities and make sure that the resumes get to the right places. Timeline wise, we're usually hiring interns in the November through January timeline for the following summer. Ultimately, when I look at an intern resume, I'm looking for obviously some experience with some programming experience, so C, C++, but primarily looking for let's say passion projects and transferable skills. So I'm looking for something that they've worked on that could be part of a class that they've done that has some relation to audio, or it could be related to any streaming media software. It could be video or audio or imaging, and I'm looking for someone who seems genuinely excited about the things that they've been working on. So I feel like if it's tough to determine who is going to make a great engineer purely based on one sheet of paper. And so if you can find something in there that pops out to signify that this is a person who is able to find things that they really enjoy and they're passionate about, that's been fairly successful for me.
So you said you're managing managers. So are they all part of the audio driver division, or are there different divisions within Apple that have the managers underneath you?
Yeah, that's all part of. So so a little bit about Apple, how Apple is structured. So you've got the CEO of the company. Underneath him, you break down into a bunch of different functional groups, one of which is software engineering. So I'm part of the software engineering group. Within that, there are a bunch of vice presidents of various things like Apple Services Engineering and home technologies. Within that, there is a vice president of media. That person is in charge of all of the software associated with video and images, graphics, and audio. So zooming down a little bit further, there's a senior director of audio, and then there's a director of driver engineering. So I report to that director, and my team is in charge of the class drivers for USB, AVB, HDMI, eARC. And then tacked on there as well, we're also in charge of Apple's home audio for Apple's home products, like the Apple TV, the HomePod, and the Apple Studio display. So it's a mix of two different things. The class drivers interface with the home products, and that's why I've ended up in charge of those things. But ultimately, pretty different skill sets across all the engineers in my organization.
So where does Logic Pro fit in that division?
Is quite far away from all of that. Logic Pro is not part of software engineering at all. That's part of like application services. I do work pretty closely with the Logic Pro team just because obviously we need to make sure that our drivers work well and are performant with that Logic Pro, GarageBand, that suite of software. But from a management perspective, pretty far away from the rest of software.
Mm-hmm. Come on, there must be other questions here. I mean, you got this Apple guy on the line here.
So yeah, I also have a couple questions too. I guess I kind of have two types of questions. One is mainly on internship. The other one is on I guess how drivers work. I guess I'll start with the driver's question. One of the questions I kind of have been wondering about is that how does, for instance, like allowing like one application to take over the entire control of a driver allows like the buffer rate, like sorry, better latency and also better stability. Because like one thing with Windows, like I guess one of the software that we use a lot in Windows is Agile for O. And one thing I've noticed with that is that it will basically causes the DAW to completely hijack the driver, and you won't be able to use like essentially if you try to play a YouTube video at the same time, it will not work. So I just kind of wonder how that works.
Yeah, so I can make some educated guesses about how that's working on Windows based on why exclusive ownership is important on macOS.
So we did 2110 to
But
get
oh,
this.
sorry.
But in this case,
Would you mind muting for sorry, he's just was distracted. So I think the concept you're talking about is hog mode. That's what we call it at Apple, and basically that's the ability for an application on the system to say, I want exclusive use of this driver and all the properties of the driver. A couple reasons why that might be important from a latency perspective, one of which is tight, precise control of the I/O buffer size can allow the application to be perfectly optimized for end-to-end latency. If the driver is able to match its I/O size with some other I/O requirement that it might have, maybe it's using a codec for some encoded audio or something, it will allow it to buffer less. So to try to explain a little better, let's say that I had the system running with a 1024 buffer size, and I decided that I wanted to open up a file that was using AC3. AC3 might be running at a 1536 block size. And so as a result, I would have to read a frame of AC3 data and use part of that to feed into the 1024 block size and save part of that for the next operation. That requires me to then buffer some amount of audio in my application, which ultimately adds to more latency. So if I'm able to say, well, I want exclusive control of the system, I could match the block size with whatever other external block requirement that I had. In this case, that was the 1536 requirement of AC3, to make sure that my block size perfectly matched that, so that there was no additional buffering needed within my application. So I don't know the specific example you're asking about, but that's probably at least related to the reason why you can get better latency by having control of the system.
I see. I guess another question I have is mainly on the, I guess the internship side question, because one thing that so I'm a junior now. One thing I've been kind of thinking about is that I've noticed just that sometimes it's kind of a choice between like going into a larger company versus a smaller company. Usually, smaller company might have like like I guess more like I guess like closer to what I want to do, but then if I go to a larger company, like they may not have as I guess like their focus might be more broad and not necessarily exactly what I want to do, but it's still audio related. So I'm just kind of wondering like what's your opinion on this? Because yeah.
Well, I mean, I'm going to give a biased answer, full disclosure, because where I ended up. But I think I went through maybe the same questions when I was in your position. Do I want to go to a big company and all of the benefits of that, or do I want to go to a small startup company? And I chose going to Apple because number one, I got lucky in that the team I joined sort of felt like a startup company, and number two, I think it was the flexibility and mobility that I saw at Apple. I sort of felt like, okay, if I ended up at Apple, there are so many teams, so many different technologies that are being worked on that it would be a lot easier for me to move somewhere else within the company to work on something slightly different than for me to have to, start again at a different startup company or something. So I really have appreciated the stability of Apple. I like the impact that I can have at Apple, and this is totally my personal feeling, but I felt like that was a greater impact than I was going to have at a startup company. So ultimately, that was what led me to the decision that I made.
I see. I think I also have. I think so. I think I also have a couple more questions. Like I think internship questions that are specifically related to Apple.
Yeah.
Do you think I can maybe like connect with you somehow through emails? Like ask you these questions.
Yeah, of
another
course.
time?
Yeah. So yeah, if anyone wants to ask Ricardo, he can provide you with my email address if you have questions, or if you want to send me your resume. If you find, so Apple has a job website that's posted. If you find positions on there, you can reach out to me. If I know the hiring manager, I could shoot him an email or something. Yeah, definitely available for that.
Okay, we have a question on the chat window.
Yeah. Let's see. Question here. Core audio feels like absolute magic after using audio software on Windows. Thank you. Yes. Okay. Do you think that Rust would slowly replace the low-level C, C++ code used for low latency audio? I'm not actually familiar with Rust. Do someone want to give me a quick overview here?
Yeah, hi. Yeah, I was the one who asked the question. So, I mean, it's a relatively new language, that has baked in, it kind of addresses a lot of memory leakage concerns and like general issues with
Okay.
multiprocessing. And like in my experience, like there is like a small group of enthusiasts who are developing BSD plugins in Rust. Uh, and this is like apart from the general atmosphere where like a lot of typical GNU tools like grep were like rewritten in Rust and like they're outperforming the original implementations. So I was kind of wondering like is there like a similar you know drive in the audio space? Is someone working on something like that? Because I would assume like if like companies like Apple are involved in it, then like this like really serious consideration. And
Yeah.
like as a student, it would make sense to learn these technologies so that like by the time we graduate, we are ready to work on them.
Yeah, I don't so I'm not super familiar with Rust. So at a high level, when I think about languages that are higher level than C or C++, dealing with audio, the concern of real-time safety always comes up. Anything that might be doing memory allocations or any kind of real-time unbounded operations under the hood can cause audio glitching. And so developing software on top of that is kind of dangerous. So I'm not familiar with this language, but Swift is something I'm very familiar with. That until very recently has not provided any real-time safety guarantees. And so you are not seeing much or any audio software that's written in Swift. For Objective-C, you can it's a little bit better, and it has a way around that, which is Objective-C++, where you can actually just write C++ code within your Objective-C wrappers. But I would be concerned about ultimately the question of, would we down the line replace low-level C and C++? Anything's possible, but when you build the higher level languages, it becomes more difficult to optimize, becomes more difficult to understand really under the hood of these calls what's happening. And the farther you abstract away from that, I think the more challenging it becomes. So maybe, but I think it's still very important to learn C and C++.
Okay, yeah, thank you so much.
Yeah.
Any other questions?
Hi, I have a quick question. So it's just kind of a general, maybe design philosophical type question in terms of you obviously, as working on Apple products within like software within the Apple ecosystem, even within the same device, you have a greater control over optimization and things like that.
Yeah.
Versus when you're forced to connect with other devices through whatever HDMI or and so forth. What kind of design decisions do you make when trying to connect with an external device versus within the hardware software ecosystem? What do you kind of prioritize in each of those cases?
Yeah. Well, when it comes to interfacing with third-party hardware, I would say a nice complete contract about what each side is going to do is important. So I was talking a little bit about how we implement class drivers, and those all follow a class spec. So there's an HDMI spec. There's a USB audio class within the USB spec. AVB has a spec within Avenue certification body. And the important thing there is really making sure that it's clearly defined what the behavior is going to be for any possible scenario or use case. So that's what I would say is maybe most important there, is making sure you've got a good design document that you're building against. And then ultimately you implement your driver to that. And then you have the third-party manufacturers implementing to their side of that. And then you go back and you verify those. So I'm not sure if I answered that very well, but yeah, I would say relying on specifications is probably the most important thing.
Yeah, I think that makes sense. Thank you so much.
Yeah.
Okay, any other questions? I have just one quick one, Adam, if you don't mind.
Yeah.
At one point you were working on USB stuff.
Mhm.
Is it still an ongoing thing with Apple, and has USB gone as far as it can go?
Wow, that's sort of a loaded question. No, I don't think USB has gone as far as it can go. I mean, so Apple just released a phone with a USB-C port on the bottom. That definitely seems to be the direction that at least the EU is pushing Apple in, and seems to be the universal connector that we're going toward. I am still managing a team that's in charge of the USB class audio driver, and that's something that we're investing a lot of resources in to make sure that that is the transport that that all of our users are going toward. I think Thunderbolt is another interesting technology, PCIe another interesting technology, but when I look out in the future toward USB and the improvements that can be made there, I don't see anything about any of the other technologies that that USB couldn't do at some point.
Okay, USB has been around for a long time now. And it sounds like it's going to be around for a long time.
Yeah, hope so.
Okay, are there any other questions? Is that something that popped up in
Well, someone said, if I'm using a class compliant USB DAC, do I need to worry about future support? Apple doesn't like to talk about future support, but I can say that my team is very busy actively supporting class compliant USB audio. Yeah.
I guess another question I also kind of have is, I wonder what's kind of the next step in like the software side of stuff for audio. Because like I'm also kind of asking because I also feel that like in terms of I think the traditional computer company, Apple is the one that has been quite consistent with like putting efforts into making their audio stuff sounds good. So I'm just kind of curious, like what general things are maybe like the general goals that Apple is trying to develop next.
Yeah, so I, again, can't speak to any future plans for Apple. I can say what I'm personally seeing as trends in the industry is all around machine learning. I think there's a ton, I mean, I'm sure you're all seeing ChatGPT and all these things, but those advances are also coming to audio applications. And I think there's some really, really cool technologies there, whether it's denoising algorithms, algorithms that are able to split a piece of composed music into all of its stems, whether it's understanding algorithms that are able to do speech to text or text to speech synthesis in ways that are realistic, human-like. I think there's going to be a lot of money and a lot of jobs opening up in those technologies. And Carnegie Mellon is like at the forefront of speech technologies. So I would, and of course machine learning as well. So if I were you, I would be taking as many classes as I could get into around how, machine learning, but also how audio interfaces with machine learning.
Okay.
Thank you.
Adam, thanks so much for being here today. It's good seeing you again. And I hope you come and visit CMU and recruit all of our students that are here.
Awesome. Thank you. Yeah. Thanks for listening to me, everybody.
Okay, I'm going to stop recording. And once again, thank you so much for doing this. Really appreciate it. And there.